Okay, young people, this is lesson 2, RT2. Let's get started. Here are your objectives. Estimate the value of a square root, add, subtract, multiply, and then in multiplying, we're going to do some division. Okay, so first slide here, estimating. Square root of 8. I know the square root of 8 is between two special numbers, square root of 9 and square root of what? Oh, shoot. Why would I do that? It's between the square root of what? 4 and the square root of 9, right? Wouldn't you agree 4 is between 9 and 8? So that means it'd be between 2 and 3. So the square root of 8 is somewhere between 2 and 3. You can make an estimation on which one is closer to. Square root of 37 would be between what two numbers? 36 and 49. Good. So we can say that the square root of 37 is between 7 and 6. Okay, they're just estimations here. How about the square root of 120? Well, it's going to be between the square root of 100 and the square root of 121. So that'd be between what two whole numbers? Yeah, 10 and 11. Okay, this is basic. You should be able to estimate those on your own without a calculator. All right, I'm not going to do this page. I think that that's something you can do on your free time if you'd like to. How about putting these in order from least to greatest? How many people, just by looking at it, would say 3 root 11 is the largest? Okay, we're all scared. How about 4 root 3? How about 2 root 7? How about 5 root 2? Which one looks like the largest one? 3 root 11, maybe? Maybe? Which one looks like the smallest one? Some would say 4 root 3. A lot of people say, hey, those two numbers, 4 and 3, look like they'd be smaller than like a 2 and a 7 or a 5 and a 2. Well, we can put these in order in a moment after I do this. Okay, with me? Square root of 99. Let's try the next one. What would that be? Square root of what? 16.3, so that'd be square root 48. Okay, so far 3 root 11 is the largest. That'd be square root 4 square root 7, which is square root 28. And then our last one would be square root 25 square root 2, which is square root, not 2, square root 50. And so now we can put them in order from least to greatest. Which one is the largest? Oh, from smallest to largest we want to go. So smallest would be this one. Next would be this one. Then 5 root 2. And then our largest would be 3 root 11. You need to unsimplify before you can put those in order from least to greatest. Okay, keep rolling, Mr. Ludd. Okay, multiplication. Multiplication is our friend. It can come in many forms, but multiplication is probably the easiest of the operations. If I want to take the square root of 3 times the square root of 2, I can bring those both under the same radical and multiply. Done. Okay, you don't have to have like a common denominator, 1, because you don't have denominators, and 2, because we're not adding or subtracting, right? Would you agree that this would be the same as square root 5 times the square root of 5? Square root of 5 squared, right? Which would be equal to the square root of 5 times 5, which is equal to what? Square root of 25, which equals 5. Let me show you a quick cool thing about when you square a square root. Okay, when you square a square root, what happened to this 5? Yeah, it came out of that radical, right? So in essence, the square and the square root cancel each other. So what would this equal? 7. What would this equal? What would this equal? Heart, right? Whatever's in there. Someone said 7? Okay? Whatever is under the radical will come out of the radical when you square it. That only works with a square and a square root, though. Okay? Or a cube and a cube root. We'll get to that later, though. Okay, let's talk more multiplication. Oh, I'm scared of this one. That's scary. Okay, multiplication is commutative, meaning that I can move numbers around. So I could move that 3 and that 2 and that square root 6 and the square root 3 around. I could multiply in any order that I want. What is 3 times 2? 6. What is 6 times 3? 18. Okay, so I have 6 times the square root of 18. Now, a JV child would say, sweet, I got an answer, I'm done. Why are you not done? Nothing wrong with being JV. I was a JV basketball player. They'd tell me, go in there and guard so-and-so while our actual point guard gets rest. And so I'd go out there, take a charge, probably take an elbow to the face, box a few people out, be sweating profusely in like 3 minutes. And then they'd say, oh yeah, hey, Adam, get back in there. And then, yeah. Okay, so I appreciate the JV in life. But why is this not done? What can I do to the square root of 18? Square root what? 9 and 2. Now, I don't know what the heck this is. I saw this happen yesterday. Some kid said, oh, I can simplify that. What? No. There's a reason we use perfect squares. What's the square root of 9? 3. And the square root of 2, we don't know, and we're not going to try to know. We're going to leave it in exact form. So the square root of 18 is really 3 square root of 2. So this is really 6 times 3 times the square root of 2, which would be 18 square root of 2. Okay, so be careful. Just because you think you've simplified it fully, look at the radical that's given and make sure that you can simplify or can't simplify before you're done. All right, let's keep rolling. Tell you what, I'm going to give you 3 minutes, 3 problems. See how far you can get. Okay, go. That was kind of weird. Okay, what the heck? This would be square root of what? 100, which reduces to 10. Done. Okay, that was too easy. Oh gosh, now I'm afraid because this square here, I don't know what that's going to do. Oh, yeah, I do. It's going to square that, and it's going to square that. So what's 5 squared? 25. 5 squared is 25. Times, what's the square root of 11 squared? 11. And that looks like 275 to me. That was fun. Okay, how about this last one over here? Multiplication is commutative, which means I can move it around like cars and stuff. They commute everywhere. So this would be 12. This would be the square root of the 90. Oh, I'm not done. You thought you were done, but you're not. Could I reduce that? Yeah. That's square root 9, square root 10. And square root 9 is 3. And 3 times 12, that'd be the 36. And so I get 36 root 10. Do you agree with that? Does it look like I messed that up? Because I mess things up once in a while. No, it's good. Okay. Okay, here's where things get fun. This is fun. Isn't this ugly? How ugly is this? Oh! Oh, all right. I want to take this problem, which looks messy, and do something with it real quick, just to show you what I mean, okay? If I take 5 times 9x, what do I get? 45x, right? So treat that square root 52 as like an x. You with me? Okay, now I have to analyze this and determine, is 52 a reduced radical? And the answer to that, I'm guessing you know, is NO. It's not, no, right? What perfect square goes into 52? 4, yep. How many times does 4 go into that? 4 goes into 48 12 times, so 13 times into 52. Okay, so 4 goes into 52 13 times. Okay, I like that. And I have 45 of those. Well, the square root of 4 is 2. So I have 2 root 13 times 45, and 45 times 2 is 90. Okay, cool, got it. Done. Okay, next one. Is there a way that I could rewrite this piece to make this maybe a little easier? If I have 2 of these, square root of 7 times the square root of 7, that's the same as the square root of 7 to what power? To the second, right? Squared. And the square root of 3 times the square root of 3 is the square root of 3 squared. So I have 3/4 times, what is the square root of 7 squared? 7. And square root of 3 squared is 3. Oh, don't do the multiplication. What's going to happen to them 3's? Chow. Your answer is 7/4. Now you're probably asking yourself, why am I doing this? Because when we find the area of a rectangle or a square or a triangle, we take the base and the height, and what do we do with them? Multiply them. And there might be radicals involved. Sweet. Okay, now we get to one of my favorite parts of this lesson, which is where I reference FarmersOnly.com. Yeah, it's true. Okay, so if I took 5x and I added it to 13x, how many x's would I have? 18, right? So if I took 5 square roots of 2 and added it to 13 square roots of 2, I'd have 18 square roots of 2. If I took 5y and added 13 x's, could I combine those? No, they're not the same variable. So that would be fully simplified. Very much like that, if I took 5 root 2 plus 13 root 3, I couldn't add those because their radicals are not the same. So FarmersOnly.com would say that these two are not compatible. With me? So let's do some maths here. So if I distributed 3 to 2x minus, I don't know, 2y, what would I get? 6x minus what? 6y, right? I'm just using the distributive property of multiplication. So in this problem right here, I'm taking 3 and distributing it to both of these terms. Okay, so that'd be 6 root 12 minus 6 root 3. Are those compatible? No, not yet. All right, I'm going to rewrite this. What is the square root of 12 equivalent to? Well, that'd be square root 4 square root 3, right? And what's the square root of 4? 2. And so I can say that the square root of 12 is equivalent to 2 square root of 3. So now are they compatible? Yeah. Okay, let me do a little math here. That's 12 root 3. And that's 6 root 3. So 12 root 3 minus 6 root 3 is 6 root 3. That was a bit of skill combined there, okay, with some background on a dating website for FarmersOnly.com. I wonder if you have to like prove that you're a farmer. If you have to like submit some kind of certificate that you've milked cows for your whole life, or you've been a part of 4-H, and you're like, yeah, huh? Oh, it is still recording. Okay, let's do it. I'm going to ask for some help from the crowd and call this hours. How about hours? Okay. Somebody help me from the crowd. How would I do the one in the west over here? This one. What do I do first? Distribute. What would I get? Wow, that's not a 28. 18 root 28. Okay. Done or no done? That's too easy. We can't be done there, right? Root 28. Somebody simplify? Anybody? 4, 7, right? So that'd be 2 root 7. So that'd be 2 root 7 times 18. Cool. So I think we get 36 root 7. Perfect. Done, right? Root 7 is simplified fully. Okay, somebody else want to assist with the second one? Thanks, Oni. Mason, what do you think? What's the first step? Yep, and then what else? 5 to the 8. What is 5 times 8, Mason? Say again? 40, good. So 40 root 18. Somebody out there with some simplification skills, what is the square root of 27 simplified? Square root 9, square root 3, right? So that'd be square root 9, square root 3, which would be 3 square root 3. How about square root 18? 9 and 2. So square root 9, square root 2, which would be 3 root 2. Okay, right now I can tell you farmers only isn't going to work, right? Do you see the square root 2, square root 3? We're not going to be able to combine them, but we can still simplify. So let me bring along with that the number that I had forgotten earlier. That's a 15. And that would be, what, a 40 and a 40. And so now we can come up with our answer. Don't forget the addition in between. That'd be 45 root 3 plus 120 root 2. And that right there would be your answer. Because those radicals are not the same, I can't go further. Done. Right? Addition, subtraction, you have to have that common radical in simplest form. Okay, let's keep rolling. Let's divide a little bit together. Now, some children they get scared by division, but division is not as bad as you might think. Okay, so thoughts. Do you have thoughts on this? I'm going to pause. So in the first one, what I would probably do is I'd probably split these up and go 3 over 9 times, and then I'm going to put this all in one square root. Okay. So what is 3 over 9 reduced to? 1/3. Good. And what would 5 over 35 reduce to? 1 over 7, right? So what I can do is then I can reduce these radicals if I can. What would be the square root of 1? 1, right? And square root of 7 is 7. So my answer, if I multiplied 1 times the square root of 1, I'd get 1. And 3 times the square root of 7, I'd get 3 square root 7. And we're good. Okay, so let's separate this into the non-radical radical piece. Oops, I want a full radical here, covering both. Okay, well, 21 divided by 7 is 3 over 1. What would 45 over 35 reduce to? What number do they have in common as a factor? 5. How many times does 5 go into 45? 9. And how many times into 35? 7. So this would be 3 over 1 times square root of 9 over square root of 7. Ooh, I can reduce square root of 9. Square root of 9 is 3. Square root of 7 is irreducible. So my answer is 9 over square root of 7. Done. Pretty easy, right? There's just a lot going on. Let's see if there's anything else. I think we might be done. Okay, let's do the togethers, and then you can start work on either these or go into Schoology and start your assignment. Togethers, FarmersOnly.com. Yes or no? Are these two compatible? Yes, their core values are the same. They love, overalls and I don't know, whatever else. 12 gauge shotguns and going out and just making noise. Okay. Okay, are these compatible? Not yet. Not yet. Could I reduce that one? Yeah, 25 goes into that how many times? 5 times. Ooh, I like that. I see compatibility here. I see what's happening here. No? Okay, bad idea, I guess. Yeah, okay. Okay, so then I get this. Okay, square root of 25 is 5, so I have 5, this 5, times 5 times the square root of 5 plus 9 times the square root of 5. And so that's 25 square root of 5 plus 9 square root of 5, which if I add those two together, I get 34 square root of 5. That's so nice. So nice. Are these two compatible? Obviously not. Will they be when I simplify it? I don't know. I don't know. Let's see. Square root 9, square root 5. Move on, buddy. Just move on. Just move on. Right? It's not going to happen. Your core values, anything that starts with lil is probably not country. Right? We talked about that before. Right? It's not country music. You like what's the new person? Little Jumps, or whatever his name is, right? Oh, that's great. I didn't want that font. I want this. I want the pen. This would be 3 root 3 minus 3 root 5. Some kid will try to combine those and say it's 0, but it's not. Because Little Jumps is not country. Therefore, core values, problem. Like, subscribe, comment below. 100th sub. Maybe we'll get you a straw hat or something. Okay. Yeah, and then enjoy your weekend. I know you're all going to be doing math all weekend. Thank you very much, Piao Gaines.